Hi everyone, my name is Santiago and I am the Developer Relations Manager at Swisstronik. This is the second video created from our team to help developers to increase their knowledge and gain more experience using Swisstronik solutions. Today, you will deploy an ERC20 token in Swisstronik and learn how to interact with it using Hardhat, ERC20 and SwisstronikJS. This video is divided into 5 main sections. In the first one, we are going to set up our Hardhat environment. In the second one, we are going to implement the ERC20 token using Zeppelin wizard. In the third one, we are going to create a script to deploy the ERC20 contract in the Swisstronik network. In the fourth one, we are going to create a script to mint tokens in our contract. And in the fifth one, we are going to create a script to check the total supply of our token. If you watched our previous video, you probably remember that SwisstronikJS is a JavaScript library used for encrypting transaction data. This library allows you to interact with the smart contracts in the Swisstronik network while also keeping your transaction data private. If you missed the video about SwisstronikJS, here is the card link for you to watch the video and share your thoughts with us. So let's keep things simple and get started. Okay guys, so the first thing that we have to do is to install Hardhat. To do that, we have to go to hardhat.org, and once we are here, we are going to click on documentation, then in quick start guide. And once we are here, we need to follow the step-by-step. So what we need to do first is to open our terminal and create a new folder. In my case will be ERC20. Then we have to go to the folder. Once we are in the folder, we need to create a new npm project or yarn. In my case, I will create the npm. Perfect. So once we create the npm project, we can install Hardhat locally in the project by running this command npm install safe dev Hardhat. Don't forget to run this command inside the folder of your project. Once we install Hardhat, the next thing that we have to do is to create the Hardhat project by running npx hardhat init. So let's just copy this command. In my case, I will create a JavaScript project. So I just click enter. Make sure you say yes to install the Nomic Foundation Hardhat toolbox. Once the Hardhat project is created, you will see these vulnerabilities. That's fine, don't worry about that. And then we can run the command code space dot to open the Hardhat project in our code editor. Once we open the VS Code, you will find all these different files and folders. To make sure that we install Hardhat properly, what we can do is to run a test that is already predefined by Hardhat. So what we can do is to open a terminal. To open a terminal, you can go here and click in terminal and new terminal. And then once you open the terminal, we can run npx hardhat test. And then you will see that all the tests are passed successfully. So that means that Hardhat is successfully installed. And now we can start editing our stuff here. The second thing that we have to do is to implement our ERC20 token. To do that, we don't need to reinvent the wheel and create everything from scratch, and we can use the Zeppelin contracts wizard. So you can just Google Zeppelin contracts wizard, and then you will find it here. Once we are here, what we can do is to give different features to our token. So for example, the first thing will be the name. In my case, will be Swisstronik. The symbol will be SWTR. The pre-mint is just if you want to mint tokens in advance. Let's just mint 10 tokens from the constructor. So that means when we deploy the smart contract, 10 tokens will be mint. And then we can add other features like mintable and burnable. We can also make this ownable, so only owner can call the function mint. And yeah, that's basically everything we need. So the next thing that we have to do is to copy the contract to the clipboard, and let's go to VS Code. Once we are in VS Code, the first thing that we have to do is to replace the lock contract for the ERC20 contract. So we can just delete all this contract, and then we can just copy paste what we have from Zeppelin. We can also change the name of the contract. As you can see, we are having an issue here. And this is because we haven't installed the dependencies yet of Zeppelin. So what we need to do is to open a new terminal, and we need to run the command npm install at openzeppelin/contracts. Once it is done, we can see in our package.json that we have a new dependency at openzeppelin/contracts. And if we go to the contract, we don't have the error anymore. Let me give you a quick explanation of what we have here in the Swisstronik contract. The first thing that we can see is that we are inheriting from 3 contracts: ERC20, ERC20 burnable, and ownable. So that's why we have only 15 lines of code in our contract itself. If we go to ERC20, the ERC20 contract has all these different functions: the name, the symbol, decimals, total supply. So we are inheriting all these functions from the ERC20. If we go to ERC20 burnable, we are inheriting 2 functions: the function burn and the function burn from. And if we go to ownable, we are inheriting all these different functions, but the main one that we are using is the only owner modifier. So this basically means that our Swisstronik contract is inheriting all the different functions and variables from all the 3 different contracts: ERC20, ERC20 burnable, and the ownable contracts. The next thing that you should do is to write a test for the ERC20 contract, but in our case, for the purpose of the tutorial, we are going to jump directly into the deploy phase. So we can go to the deploy script, we can remove these comments, and then let's write our script. The first thing that we have to do is to create a constant of the contract, so we can deploy the smart contract. Make sure that the name that you are putting in this string is the same name that we have here in the contract. So in our case will be Swisstronik. The second thing that we have to do is just to wait for the deployment of the contract, and then we can print the address of the deployed contract. Before we deploy the contract to the network, we need to edit the hardhat.config.js file with 2 things. The first one will be the Swisstronik network, and the second one will be the private key of our wallet, so we can deploy the contract. So let's add Swisstronik network here. We need to add 2 things. The first one is the URL of the RPC node, and the second one is the private key of our wallet. For the URL of the RPC node, we can go to the documentation of Swisstronik, connect wallets, MetaMask manual, and we will find the RPC URL here that we can just copy paste. And for the private key, we need to go to MetaMask or our wallet. We can click on account details. We can click on show private key. We put the password, and then we can copy paste the private key into the Hardhat project. The next step is to paste the private key here, but for best practices, what we are going to do is to create a .env file. Something that you have to know is that the private key must start with a 0x string, and then we can put the private key here. So let's create the .env file. And let's paste our private key here. To make this dependency work, what we need to do is to install the dependency .env. And this dependency will help us to read the private key from .env file without compromising the private key to GitHub or any other files in the Hardhat project. To make sure that .env is successfully installed, we can come to package.json, and you can see it here in the dependencies. The next thing that we have to do is to import the .env config, and then we will be able to deploy the contract. To deploy the contract, we need to run the command npx hardhat run, and then we need to run the script, and we need to put -- network Swisstronik to make sure we are running that in the Swisstronik network and not in the Hardhat network. Before we interact with the smart contract, we need to install SwisstronikJS. So to install SwisstronikJS, we are going to run the command npm install at swisstronik/swisstronik.js. To make sure we successfully install SwisstronikJS, we can come to package.json and we will see it here. Now we're going to create a script to check the total supply of our ERC20 token. So let's create a new script. Let's call it totalsupply.js. The first thing that we need to do is to import Hardhat. Then we need to import SwisstronikJS. The two main functions that we have here are encrypt data field and decrypt no response. So what we are going to do now is to write the main function that we are going to divide into three main steps: get the signer, create a contract instance, perform a shielded query, and after that we are going to implement the shielded query function. So to get the signer, we just need to use the get signers function from ethers.js. This will return an array with the signer objects, and that's why we are catching the result of the first position. To create a contract instance, first we need the contract address. Contract address. Then we need to create a contract factory. Make sure that the name that you put in the contract factory is the same name as you have on the contract. After that, we can attach the contract factory to the contract address by typing contract factory.attach contract address. Now we can perform a shielded query. This is a function that will receive three parameters: the provider, the destination, and the data. So let's create three variables here. To get the provider, we just need to use signer.provider. The destination will be the contract address. And for the data, we need to encode the function name and the function arguments. To do this, we can use the contract interface to encode the data. This function receives two parameters. The first one will be the function name, and the second one will be the function arguments. So in this case, the function name will be total supply, and the function arguments will be empty. Now that we have all this information, we can perform a shielded query that will receive the three parameters: provider, destination, and data. Now we can implement the shielded query function. This will be an async function that will receive the provider, destination, and data. And we will divide this function into four main steps. The first one, to get the RPC link. The second one, to encrypt the data using SwisstronikJS. The third one, to execute the call. And the fourth one, to decrypt the node response using SwisstronikJS. So to get the RPC link, we can directly copy paste the RPC node from Swisstronik, or we can use this property from Hardhat to get the RPC link as well. Now it's time to use the first function from SwisstronikJS, encrypt data field. This function will return two variables: the encrypted data and also the encryption key. So let's call it here. This function will receive two parameters: the RPC link and the data that we have to encrypt. Now we can call the provider that will return a response. We need to send two parameters. The first one is the 2, that will be the destination, in this case the smart contract address. And the second one will be the data, that is the encrypted data that we just encrypt using SwisstronikJS. When we execute this call, we are getting an encrypted response. So that's why the last step is to decrypt the node response using the other function of SwisstronikJS, decrypt node response. This function will receive three parameters. The first one is the RPC link. The second one is the encrypted response. And the third one, the use encryption key that we previously used to encrypt the data. Then we can return this function from the shielded query, but this function will return an array that we will need to decode to be able to understand it. That's why when we receive the response here, we need to decode this value using the contract interface and the function decode function result that will accept two parameters. The first one is the function name, and the second one will be the encoded response that we need to decode. After that, we can print the value, decoded value here, and before we call the shielded query function, we need to write await because this is an asynchronous function. After that, the last thing that we have to do is just to call the main function, and then we are ready to run the command npx hardhat run scripts / total supply.js -- network Swisstronik. And as you can see, the response that we got was 10 to the power of 18. This is because when we deploy the smart contract, we mint 10 tokens in the constructor. Now it's time to create a script to mint tokens. So let's create mint.js. We can import the same modules here, and then we can write the main function. This main function is almost the same as the main function in the total supply.js, but the only difference is that instead of performing a shielded query, we are going to perform a shielded transaction. So this function is divided into three main steps. The first one is to get the signer, the second one is to create a contract instance, and the third one to perform a shielded transaction. For the first two steps, I can basically just copy paste the same first two steps of the main function of the total supply.js script, because nothing is changing. We are getting the same signer and we are calling the same contract instance, the same address, the same name. So that's why I just copy paste that. And the last step will be to perform a shielded transaction. This will be a function that will receive 4 parameters. The first one is the signer, the second one is the destination, that will be the address of the smart contract. Then we have the data of the function that we want to call, and the value, in case that we want to send some value to the contract. This will return a transaction object, and then we can wait until the transaction is executed. So let's create the variables that we are going to send to the shielded transaction. In this case, the destination will be the contract address, and to encode the data, we need to use the contract interface and the function encode function data. This function will receive 2 parameters, the function name and the function arguments. In this case, the function name will be mint, and the function arguments will be an address to which we will mint the tokens and a number with the amount of tokens that we will mint. So this will be an array with the 2 and the amount. Let's create these variables. So the 2 address, I will just put a random wallet address here, and the amount, let's mint 50 tokens. Something that we should change here in our contract is that when we call the function mint, we should multiply the amount for 10 to the power of 18. In this case will be the decimals. But I will not do this because I will need to redeploy the contract, and for learning purposes it's fine like that. And the last argument, that will be the value, that in this case will be 0. After this, we are ready to implement the shielded transaction function. That in this case will be an async function that will receive the parameters the signer, destination, data, and value. And this function is divided into 3 main steps. The first one is to get the RPC link, the second one to encrypt the transaction data, and the third one to sign and send the transaction. So the first step is the same as we did for the shielded query in the total supply.js. So we will write const rpc link. For the second step, we need to use the encrypt data field function from SwisstronikJS. This will receive 2 parameters, the rpc link and the data that we need to encrypt. And this will return the encrypted data that we need to send the transaction. Remember that all the transactions are encrypted in Swisstronik, so that's why we need to send the data encrypted. Otherwise, the node will not be able to read and decrypt the data, and the transaction will fail. And the last thing that we have to do is to sign and send the transaction. So we are going to return the transaction object. Send transaction. This will receive 4 parameters. The first one is from, to, data, and value. The from will be the address of the signer. The to in this case will be the destination, that is the smart contract address. The data will be the encrypted data that we just encrypt using SwisstronikJS, and the value will be 0. So before we run this script, we just need to call the main function, and then we can open the terminal to run npx hardhat run scripts main.js network Swisstronik. So as you can see, the transaction was executed, and we can also double check by running the command of total supply to see if we have minted new tokens. And as you can see, we have minted 50 tokens successfully, but if you want to mint 50 times 10 to the power of 18, what you need to do is to come here and change this mint function to amount times 10 to the power of decimals, that in this case will be 18, and then you can redeploy the contract and run the commands again. And that's how we can deploy and interact with an ERC20 token in Swisstronik. Just keep in mind 2 main things. The first one is when we send transactions to the blockchain, we need to use the encrypt data field function to encrypt the data before sending the transaction. And the second one is that when making calls to the blockchain, we need to first encrypt the data. After that, we can make the call. And finally, we can decrypt the response from the node using the decrypt node response function from SwisstronikJS. If you want to learn more about Swisstronik, I will drop the link to the documentation in the description. Thanks for watching, guys. See you soon.